This is problem 9 of section 2.1. So for this one, they want us to use the alternative form of the derivative to find the derivative at x equals c. So the alternative form for this is that f prime of c, looking at a specific value of x, in this case c, is going to be equal to the limit as x approaches -2 of f of x minus f of -2 over, well, I've already jumped in and put c in there, -2 in for c, but x approaches c of f minus c, x minus c. Okay, now let's expand that. We know that c is equal to -2. So for f prime of -2, we have that this is going to be equal to the limit as x approaches -2 of f of x minus f of -2 all together over x minus -2. This gives me the limit as x approaches -2 of f of x minus f of -2. And so that we don't have. So I'm going to kind of pause here and kind of do some side work. Let's look at what f of -2 is. So we're evaluating this function for -2. So I have -2 to the third. I'm just replacing that x with a -2. And this is going to be a -8 plus this is going to be -2 squared will give us 4. This is going to be a +8, and then we have 9. So then here we're going to get 0. We're going to have a +9. So this right here, we're going to get 9. And we'll go from there. We have x plus 2. Let's go ahead and plug in f of x now. So we have the limit as x approaches -2 of x to the third plus 2x squared plus 9 minus 9 over x plus 2. And then we're going to have, this becomes the limit, the 9 plus 9 minus 9, those combine to give us 0. We have approaches -2. We have x to the third plus 2x squared plus 9 all together over x plus 2. Now, when I look at this, it looks like the function is it's not defined at -2. So we want to evaluate this limit further. A mistake that I just noticed, let's cross off that 9, right? Because we combine them, 9 minus 9, those combine to be 0. All right, that will make our function a little bit better. Our limit a little bit easier to evaluate. From there, we look at the limit as x approaches -2. And then here, this numerator does factor. We can factor out an x squared. So I have an x plus 2 over an x plus 2. We know our theorem that we use all the time. We say x does not equal -2. So we can find a function that agrees with our given function at all but one point. So this then becomes, it's going to have the equivalent to the limit as x approaches -2 for the function x squared over 1, or just x squared. And this one we can directly substitute -2 in there. We have -2 squared, and then this equals 4. So then this equals 4. This works if you're going to just evaluate the derivative at one specific value of x. But if you're going to evaluate it for many different values of x, I encourage you to find that derivative function and then plug in the different values of x that you're considering. Okay, thank you.